Hello and welcome to another video lesson. In this module's video lesson, we're going to expand on last week's problem of determining if an expression is properly balanced. We're going to incorporate that into this larger problem of solving arithmetic problems using stacks. So I'll go ahead and I'll read through the requirements and the description of the problem. So the first thing it says is to create a program that allows the user to enter an arithmetic problem using addition, subtraction, multiplication, and division of integers. We need to assume that the user will only enter single-digit numbers. Assume that the user, when it comes to division, will only enter numbers that result in an integer quotient, so no fractional answers. Assume that users will enter all multiplication and division operations within a set of parentheses, and it gives the example 2 times 3 within parentheses plus 4, and not 2 times 3 plus 4 with no parentheses around the 2 times 3. Assume the user will only enter arithmetic problems that result in a single-digit result. And then here's a sample run of the program. Enter an arithmetic problem. And then it shows the 2 times 3 in parentheses plus 4. And it shows the result is, and then the result is 10, shows a 10. The same thing with a different user input. So it says enter an arithmetic problem. 9 divides 3 in parentheses plus 3 times 2 in parentheses. The result is 9. So there's some software requirements here. It says to ask the user to enter an arithmetic problem, and the problem must be valid. And then we must also have 3 stacks to store the appropriate data as indicated below. The first one, the operand stack, this is not going to be used to store parentheses. The operands are going to be the integers that are being operated on. So this stack should be responsible for storing the integers that the user has entered, and we will store them as they come. So ignore that it says this is for open parentheses. The character stack, the char stack, this one is responsible for storing the open parentheses of the arithmetic problem. And this will work very much the same way it did in the last module where we did expression balancing. And then finally, the operator stack. This stack is responsible for storing the operators of the arithmetic problem. So that would be your addition, subtraction, multiplication, and division. That's it. We'll go ahead and we'll get underway. Okay, I'll go ahead and I will minimize this and open up the code. So you're going to notice immediately that I have some stack implementations and header files here. And I can briefly go over them, but the whole point of this lesson isn't to teach you about the implementations of these. It's to solve a problem using them. So there are other lessons in the modules before that go into detail about the implementation of the stacks, and you can refer to those if you need to. But I have an image here that I wanted to talk about a little bit, and it is, it is basically the rules that we're going to use to determine kind of like how things are going to appropriately function in the code so that it performs the operations appropriately. And this idea is discussed in the Solis video that I have included in the module. And I've just kind of written down some of the rules that were the mainstays of that explanation. So for rules, so these rules apply specifically to when we're iterating through the expression. So this is going to apply to the for loop that goes over every character in the user input. That's what these specific rules are for. So when we come across an opening parentheses, we're going to push it onto the character stack. When we come across an integer, we're going to push that onto the operand stack. And when we come across a plus, minus, multiplication, or division, we're going to push that onto the operator stack. When we get to a closing parentheses, we have a few more steps that we need to take care of. So when we run across a closing parentheses, let me see if I could get a little closer. Oh, I see what I'm doing. I'm not actually enlarging the image. That enlarges the image. Okay. So when we come across a closing parenthesis, we need to pop the most recent item from the character stack, and then pop whatever's at the very top of the operand stack, pop the top of the operator stack, and pop the top of the operand stack again, respectively. So for each stack, do this. Then we're going to perform the resulting operation from the things that we popped, and we're going to push this result back on to the operand stack. So this would be like, for example, the 3 times 2. We would pop the 2 would come, and then we'd go to the operator stack, and then the times would come out, and then we'd go back to the operand stack, and then the 3 would come out, and then from these we would perform the operation between all of them. And then that result is now going to go back on to the operand stack. When the iteration is over, so when we're done looping through the user input, if the operand stack is not empty, we're going to perform the operation in the same way that we did when we get a closing parentheses. And that's going to be the basic gist of the rules that were kind of outlined in the previous video. All right, so like I mentioned, we have some, let me close this. Like I mentioned, we have some stack implementations already outlined. So we have the character stack implementation, or the header file, I'm sorry. The character stack header file here. Let me make this a little smaller. And then we have a integer array stack header already created for us. And what we need to worry about is the main code. So this integer array stack has the exact same methods that we talked about in the previous module that all stacks have. A method that checks if the stack is empty, a method that pushes things onto the stack, that pops things off of the stack. Peek is a way to see what's at the top of the stack. It doesn't delete, it just shows you what's at the top. And then display, a method that displays the contents of the stack. And both of these stacks, the integer array stack and the character stack, have the same methods associated with them. Okay, and then you might be asking yourself, okay, well, we have 2 implementations, right? We have a stack that stores characters and we have a stack that stores integers. And we're supposed to have 3 different stacks. Well, the stacks that store characters are going to suffice for the operand stack and the character stack for the parentheses. So that takes care of 2 of them. And then because the plus signs, the minus signs, the division signs, those are all characters. The integer stack that's going to get the operands, that's of type integer, so that one does need to be different. So we will have 3 different stacks, but we require only two data types between them, something to store characters and something to store integers. So I'll go ahead and I will open up a I'll create a new file. It will be called source.cpp. And then we can go ahead and get started on our code. All right, so first things first, I need to include some things. I'm going to include IOStream for user input and output, and user input, and then whatever output we create. And then includes the string library. We are going to perform string manipulation, so we need this library. We want to include charstack.h so that we can have the operations that are outlined on the character stack header file. And then I want to include integer array stack as well, so I could use that. And then using namespace, I don't know why that happens all the time. I guess I get a little too excited. Namespace std. Okay. And as mentioned previously, this is going to build on last modules lesson. So we are going to have a function that is going to return a Boolean, and it's going to be called is, should be called is expression balanced, and it's going to take a string, user entry par. So these are our function prototypes. And then we're also going to have a special function that is going to get an integer. So we're working with user input that's going to be string when we use the getLine function to get the expression. Those are strings. So the user input will be in string format. So we need to do some type of a conversion. So we're going to say get integer string user entry par int address of the starting position, passing by reference. Start position. Okay. And then we want to save. I saved right now. We're going to create a stack pointer, and it's going to be called parens stack ptr, and it's going to be a new character stack. We're going to do the same thing with integer array stack pointer operator and stack pointer equals new integer array stack. And I am using autocomplete very cautiously because sometimes it completes in a way I don't want it to. So we also need another character stack. And this one, so we need one for our parentheses, and we need one for our operators. So let's say operator stack ptr equals new char stack. Save. Okay, so those are going to be our pointers to our stacks, and then we need to create the main function, return 0. Okay, I'm going to save. All right, so let's create some declarations. And we need a string to store whatever the user puts. And this is going to be for the user input. And then we need a couple of variables for the operands because we are going to be using the operands later within the main part of our code. So we want to make sure there's space for that. Operand 1 to store the first and second operands for, hold on, I'll complete this. Operand 2 to store the first and second operands for, let's call it direct calculation within the main. And then we're going to have a storage for results, and we're going to have a temporary space for operators before we use them. We'll temporarily set this to A, and then this will be used to store operators before use. Okay, and I think from here, we can move to the get user input portion. Get user input. So we have some we made our declarations. We have space for everything we wish to work with within the main function. And we're going to say cout. It says enter an arithmetic problem. So it's going to say enter an arithmetic problem, : space. Let's see. Yeah, it should be fine. And then let's give more direction to the user. Your equation expression must place parens around. And then we'll say cout any multiplication or division operation. And then we'll put space there, and then that should work. And then we don't want to do a cin simply. We want to say getLine because this will likely be, this input will likely have spaces in it. So we'll say user expression. Use getLine to include everything. Everything the user puts before the return carriage. So that's what that is going to do. And then once the user inputs, we want to check if the expression is balanced. So first, determine if expression is balanced. And the way we're going to use this is we're going to use a while loop. And the while loop is going to use the terminating condition of if is expression balanced false, then we're going to continuously prompt the user to enter in something until it meets the requirement of our the user input requirement. So let's go ahead and just code this out for now, and then we'll go back and we will define this function. So we'll start by saying while is expression balanced, and then it's going to take user expression. That's what I called it up here, just making sure. User expression false. Then we want to tell the user your expression is not balanced, right? They need to know. And then we will tell them the requirement again, enter a math expression with parentheses. Or however much more descriptive you want to be with it, that's fine too. Just format your output so that it looks reasonable. And then we'll continuously get the user's input until they give us something we can work with. Okay, so next we are going to define the isExpressionBalanced function. I don't have to copy it from here. I can actually go to the prototype, copy it, scroll down to the bottom, and then create some curly braces. So again, last week in the last module, we discussed the finer details of checking if the expression was balanced using parentheses. So if you feel a little lost in the explanation of this, please refer to that module for more detailed information about how this works. But the basic gist of it is that we are going to keep track of our parentheses. So we're going to iterate over each item in the user input. And if it's an opening parentheses, we're going to push it onto the stack. And if it's a closing parentheses, we're going to check if the stack that holds the opening parentheses is empty. And if it's empty, it means that there's no pair for that closing parentheses, and then it's not balanced. So that's basically how the logic is going to work for this. And there's a couple checks at the bottom too, and I'll lightly go over them as well. So we need an integer variable for the length. We need a Boolean variable that is going to keep track of whether or not we've evaluated the expression yet. And then we're going to let length be whatever the user put that length. And we're going to use that to iterate over the user input. So we're going to create a for loop, start at the 0th position while I is less than however long the string is, increased by 1, and go over each item, not square braces, curly braces. That's much better. No, it's not. Okay. That was painful. All right, so if the paren stack, no, not paren stack, let's think. If the user entry at index I is an open parenthesis, that's correct. If user entry par I is opening parenthesis. We said that if this is true, we want to do something. We want to push it onto the stack. So we're going to say parens stack ptr push. And then we're going to push what that element is. It's an opening paren, but we're going to push it on there. That's where it goes. That's how we're keeping track of whether or not the expression is balanced. Okay. Then we have else if, and then some other condition. And the condition here is user entry par at index I is a closing parenthesis. That looks like this. If it's a closing parenthesis, then we need to check, all right, is the stack empty? So we say if parens stack ptr is this, use this method empty, and then evaluates to true, so it is empty. Then we are going to output, oh yeah, your expression is just not balanced. Your expression is not balanced. And then if you want to do any other interventions here, you can. For us, we're just going to say is evaluated is now true. We've evaluated it. I'm sorry, is evaluated. Save that. And then after that, we don't need to do any more looping. Once you find one thing wrong with this, the whole thing won't work. So we could break at this point. Okay. There's another condition here. Parens stack ptr is empty is false. So otherwise there's something on it, then we can pop whatever it's on it. And we already know whatever's on it is an opening parentheses. That's all we're putting on this stack. So it's no mystery what's in there. And then that would be, we're assuming that that is the opening parens that goes with this closing parens. So we will say parens stack pointer pop. That looks pretty good. All right, I need to keep track of this for loop here. So I am actually going to copy this, and then it goes here. And I did this, I showed this in the in last week's module too. If you have a program that kind of has a lot of for loops, it's easy to get lost, or just nesting in general. It could be useful to include something like this to keep track of that. Okay, that's all this is. So then we say, so then we get to the end of the program, and then there's a couple of checks that we need to do. So we'll say if parens stack ptr is empty. So if it's empty, true. And we haven't evaluated yet. I'm doing that. Then we are going to return true. So if the stack is all empty, it means that every opening parenthesis that we put had a closing parenthesis on it, and then we haven't evaluated it. So now we're going to evaluate it, return true. That would mean this expression is balanced, and when we use return here, it's going to break us out of the function. Okay, so then we say else if some condition parens stack pointer is empty is, let me put a space here to be consistent, false. So if there's something left over on the stack, again, it's going to be an opening parentheses, that's all we're putting here. It didn't have a matching closing parenthesis. That's why that's still there. We can only pop when we get to a matching parenthesis, matching closing parenthesis. So this one's going to return false. And then we need to just return false anyway. Just again, I think this turns off warnings if we get to a situation where either of these don't work. We're just going to assume this is false, and we're going to return false, so that our function definitely gets to return return a Boolean no matter what. Okay, and that is all the logic for the is expression balanced function. Okay, now that that's complete, we can get to, we can go back to the main part of our code, and that will complete this portion. So next we need to go through, so it's balanced, we already determined that the expression's balanced. Now we can implement the logic of our code that we talked about in the image. So again, in the image, we have some rules for opening parentheses, integers, operators, and closing parentheses. We're going to implement this logic that we went over earlier. So the first thing we need to do is create a for loop to go over everything inside of the whatever the user put. So we're going to say for int I equals 0, start at the first thing, I less than user expression length, I plus plus. This one's going to be a little long, just warning you. So we're going to say if, let's put a space here, oops, user expression at the ith position is an opening parens. Looking at that, that looks fine. Then we want to push it onto the parens stack pointer. So we're going to say parens stack pointer push. And then what do we want to push? Whatever user expression is at the ith position, which is an opening parens. So that's what happens if we come across an opening parens. If we come across, or else if we come across like an operator, so we'll say user expression I is a plus sign, and then I'm just going to fish around on my keyboard for a plus sign, or user expression at the ith position is a minus sign, or, and then this is going to get a little bit long, bear with me, user expression at the ith position is a multiplication sign, or user expression at the ith position is a division sign. Okay, and I'm sorry it cut off. Let me see if I can scroll back. So if the user expression at the ith position is any of the operators, then we want to put it on the operator stack. So we say operator stack ptr push user expression at the ith position. So we've already checked to make sure that it's an addition, a subtraction, a multiplication, or a division. All right, we'll save, else if. So now we want to check if the value is an integer or an operand. So to do this, we're going to employ the isDigit function, and we're going to use it to check user expression at the ith position, and then line up your parentheses correctly if that'll make the difference. And then if it's not 0 and it's a digit, if this is a digit, push the number onto the stack. Great. And this goes on our operand stack, and then we push it, and then push. And we want at this point to make sure that what we're pushing is a number. And we created a function that does this, or we're going to create a function that does this, calls get integer user expression comma I, takes 2 parameters. And we'll go over this in a moment. Let's move on and finish off this last part, this last else if. Else if, let's actually not do that just yet. Let's go ahead and define our get integer function. Okay, so I'm going to scroll up, and I'm going to get this. So this is the only other function that we're going to be using. Let me minimize this here so you can see better. And that goes here. And then the definition is going to go here. So in the source code, so in the reference code that's included in this module, all these notes will be here, and more notes that go a little further into detail about what everything's doing. The reason that the starting position is going to be passed by reference is because it's a counter that's going to be used within a for loop in our function. So the counter incrementing here needs to also increment with the for loop that it's in to remain consistent. And I'll include more notation about this in the reference files. So we need a few of the variables. So we'll have a string next integer equals quotation marks, and then we'll have a boolean that says dot next integer equals false, temp char. Okay. And there is going to be some piece of this code that ensures that I know that the requirements say we only get single values, but this will actually allow us to get multi-digit input. So, or at least integers, right? So the way we're going to do it is we're going to want to, so we're going to use got_next_integer, the Boolean variable, to stay in the loop until the entire number is read. So if this is a multi-digit number, we want to stay in the loop until we finish reading it. So we're going to say while got_next_integer is false. So while we haven't got everything, here's what we're going to do. And then I'll put some notes here until the whole number is read. So stay in here until we read the entire thing, and then we're going to, let's see, we want to add to the first digit. So we want to say next integer equals next integer plus user entry var dot substring, we're getting a substring from the starting position to 1. So this just adds the first digit. And then I'll put a note here. The first digit. Okay. And then we want to do a conditional after this. So now that we got our first digit, let me go back here. I'm going to save. And then I'm going to say if the start position is user entry var dot length minus 1. So what we're saying here is if we're already at the last number, we're going to return right away. So so even though we have this while loop that says false, we want to make sure that if we've already had the whole thing, just return it right away. And then the action here is return string to integer. That's what STOI stands for. Next integer. And then here's a note that says that this is the string to integer conversion. Okay, and then else, so if not, we want to move to the next character. So what we need to do is we need to move the starting position by 1. So we'll say start position plus equals 1 plus equals increments by 1. And this is to move to next character. Okay. All right, let me go ahead and save. Okay, so at this point, the start position variable has just been incremented. So now we're going to look at the character immediately after the current digit. So here I want to say temp char that the temporary character variable that we created to store the user entry parameter dot at start position. And I'll put some notes and I'll talk about this a little bit. Return the character specified at the index. Okay. So it's checking, is this another digit? And if it is, we're going to keep building the number. And we're also saying, is this something else, like a plus, a minus, a space, etc.? And if it is, we're going to stop building the number. So we need to do this because we need to know when to stop collecting digits. So for example, if the input is 1, 2, 3 plus 4, and we're starting at index 0, we read 1, then 2, then 3. So then now we peek ahead and see a plus sign, which is not a digit, and that tells us to stop building the number so we can just return 1, 2, 3. If we didn't peek, we might actually include a non-digit character in the number string or stop too early. So I hope that helps with this. And I did say we were going to use string manipulations in this code. So now we need to check. We need to do another check. We're doing a lot of checks in this code. And we need to check if the character is a digit, and then we go to the top of the loop. And so we say if is digit, and then temp. So if the thing that's coming next is a digit, so we say is 0, and then I'll put some notes here. If this is a digit, go to the top of the loop and add it to next integer. And I'll keep trying to be mindful that you guys can see everything I'm seeing. And these the notated resource files are included in the module. So if you don't get everything, it is included in the resource module. Okay, so if this is a digit, we will say got next integer is false. Okay. So then we don't have to do that anymore. So we say got. So remember the got next integer, while it is false, we're going to stay in the loop. So if this is a digit, we're going to go to the top of the loop and we're going to continue. Else, if it's not a digit, we need to finish. We're done and we could terminate the loop. So we will say else, and then I'll put some notes here. If not a digit, we're done. You don't want to keep going, right? I represented that there is a situation, a hypothetical situation where we have 1, 2, 3 plus 4. This would be that situation where, oh, it's a plus sign. You know, it's not a digit. We are done. We could just return whatever we have so far as the number. So we will say got next integer is true. And then this is the terminating while loop condition. This terminates the while loop. And then we will say start position minus equals 1. And then I'll put some notes here. If user entry par is 13 plus 4, with an example. I'll change this to 13 plus 4. Then, yeah, so I'll include a better example of this. Let me just get rid of this, and then when I finish, I'll go ahead and I'll upload it to the module. But start position needs to be decremented back by 1, and this happens inside the get integer function that we're coding right now, where we're reading a sequence of digits from a string. So like 1, 2, 3 plus 4, like we keep saying. Let's suppose that the user entry parameter is 13 plus 4, and start position is currently pointing at the 3. So this is the point right before the plus sign. So then this would be, let me write some of this down. If user entry par is 13 plus 4. Right, so if we're talking about if we're at this position right here, right before the plus sign. So we enter the loop and build the string to 13 using the substring process that we did before. So we did substring start position 1 up here. Where are you? Right here. Now, after reading the 3, the starting position becomes 2. 0, 1, 2. That's this plus sign here. That points to the plus sign. We check the plus sign and we realized it's not a digit. So we know we reached the end of the integer, but there is a problem with this. Now, starting position, start POS is at position 2, where the plus sign is, but the main for loop in the main function is also incrementing the position in the original string. So I said this was going to be a little bit tricky, and I mentioned earlier that we are actually taking in, we're passing in by reference because we want to directly amend this value. So this is a little tricky. And we want to directly amend this value in the main part of our code as well, the part that has the main for loop in it. If we leave starting position at 2, the for loop will increment I again to 3, and it's going to skip over the plus sign entirely. So to prevent this from happening, we need to decrement the starting position before finishing. So when we return to the for loop in the main part of our code, the main function, the next I++, the next incrementation of I, brings us right back to the plus sign where we were supposed to be, letting the logic process it, like pushing it onto the operator stack. And that's why we're doing that. So I'll go ahead and I'll leave it there. And then this is a while loop, and I said that if we get a little big, we should just copy this over and try to keep everything together. Ooh, looks like we looks like I must have deleted a closing parenthesis somewhere. So I will close it again, and then this should be for the while loop, and then that should fit fine. So if you're following along, just try your best to keep up with the parentheses and the curly braces. Okay, and bear with me while I reevaluate where I am in this code. So I have an else if the is digit, we wanted to push that value onto the stack. So that's the that's this portion. Now we need another else if for the situation where user expression at that position, at the if position, is closing parens. So if it's a closing parens, we need to pop the parens stack, whatever's at the top, which is it's an opening parens, in a very similar way to how our expression balancing logic works. We're doing something kind of similar here as well. We're using this logic kind of in a similar way. And we're going to say parens stack ptr pop. We're going to say that this removes the initial parens. And then we want to do the same thing with operand 2. Again, we went over this in the image. This was also went over, the rules are went over in the image that I outlined at the beginning of the video, where we pop the most recent item from the character stack, and then pop the top of the operand stack, pop the top of the operator stack, go back to the operand stack, pop the next one, and then perform whatever operation needs to be performed on those two operands. So operand 2, operand stack ptr pop. Okay, and I'm going to do something very similar for operand 1, except I'm going to change this to a 1, so that should be fine. So I've popped the top two things off of that stack, and then we're going to use the temporary character holder to take the operator stack ptr pop. And then this is fine. I'm going to save it. And then we need to solve the operation and push the result back onto the operand stack. So this is just going to be a very simple conditional statement. This is just going to have, okay, if the character, if temp char is a plus sign, add the operand 1 and operand 2. If it's a minus sign, subtract operand 1 and operand 2. It's not going to be very complex. So we're going to say that this is going to solve operation and push result onto the operand stack. So I'm actually going to try to do some copy pasting here to make this go a little faster, because I think this part's this part's easy for us, right? And then this one's going to result is operand 1 plus operand 2. And let me think for a second. Else, we're going to have something. I want to be really careful with those opening and closing brackets. Else, if it's a minus sign, here's some more brackets. Uh-oh. Okay, I'm a little scared with these. You know what? Actually, I'm actually going to copy this here. I'm a little spooked. Okay. That's what that's to. And then this for loop is to this. Whew, okay, that's a little more comfortable. Now I know where everything goes. And then this is going to be very similar to this, except it's a minus. Okay, and then we're going to do, now we can effectively copy these. And then I'm going to tab these over. Else, if this is a multiplication, then we do multiplication. And then else if, and we'll tab this in, this is going to be a division, then we perform a division. It looks a little upset. It says, hey, I think you have an extra one of these. And then I'll kind of go through everything and make sure that we're good. That looked a little weird. Open, close. Oh, this looks so much better. Okay, opening, closing, opening, closing, opening, closing. Okay. One of the cool things in Python is that you don't have to use these curly braces for everything. Actually, everything works based off of indentations, which is really nice. There's also, we can also accommodate for if somebody used, if somebody used an X sign. And what I mean by that is if this is like an X, then we can accommodate for that. And that looks pretty cool, so we'll do that. Okay. Kind of nice, just making our program robust, right? And then after all of this happens, so after we have assessed, all right, did we need to add, subtract, multiply, or divide, then we will now say operand stack ptr push result. Then I'll save that. Okay, and then that is going to happen for the remainder of the user input. So at this point, we're going to pick up to what happens when the user input has been exhausted. We've gone through everything. So we're going to say that at this point, the stacks contain addition and subtraction. Remember, because we said that we want all of our multiplications and divisions to definitely be put inside of parentheses. We said that to the user. So at this point, if there's anything left over in the stack, it's going to have addition and subtraction operations in it. And we're going to say to solve the remaining operations and clear the stacks. So we're in the home stretch. We're almost done. So all we have to do here is say while operator stack has stuff in it, operator stack pointer is empty, is false, so there's stuff in there. We're going to actually copy paste some stuff. We're going to do this. Where are you? There you are. We're going to say operand 2, pop it, operand 1, pop whatever's on the operand stack, get the 2 items from there, and then since there's 2 of these, get the thing on the operator stack. Pop. And then this gets the operator. Okay, and then we're going to solve the operation and push the result onto the operand stack. So while we're still in this while loop, we want to solve operation and push result onto operand stack. I feel a little optimistic because we're almost done. This one was kind of long. But we're doing a lot of learning. And this is the last lesson you guys have about stacks. So let's see, we'll say result operand 1 plus operand 2, and then else if it's subtraction, temp var is subtraction. Then we are going to do this, but with subtraction. Not too bad. And then once we've evaluated that, then we are going to push it onto the operand stack. Push. And then what are we pushing? Whatever the result is. And yeah, that's going to happen well, it's has stuff in it. Well, the operator stack has things in it. So then after that, we want to display the result of the user expression. And we're going to say cout. The result of your expression is operand stack pointer pop. Ooh. Sorry about that. Okay, so the idea here is that, remember, every time we had a result, we pushed it onto the operand stack. And this result kept getting pushed on and on and on for however many operations we needed to do on our operands. And so whatever's left on the operand stack is the result. So we're going to pop the top element, should be the only element. And then after we do this, we're going to release our resources because we did create them on the heap and they need to now manually be freed up. Remember, we use the new keyword. All right, so that means we allocated resources to the heap. So let's release them manually with our delete keyword. Delete parens stack pointer, and then parens stack pointer is now the null pointer, right? Because they were pointers and we need to make sure to delete them. Operand stack pointer, operand stack pointer is null pointer, and then one more. Operator stack pointer, operator stack pointer is null pointer. And then I save. Okay. All right, it's time for the moment of truth. We're going to run this thing. So I'm going to open up a new terminal. I know this is a little small, but I'll just spell out what I'm doing. So I say G++, and then I give the names of the implementation files and my source file. So it's source.cpp, integer array.cpp, space char stack. Oh, I spelled integer array without the word stack in it, so I'll add that there. And then now I can put char stack.cpp. I can put -g, which is the switch for debugging, -o, the switch for compiling, and then a out, the name of my executable. I hit enter, then I run it. I already sound a little scared, right? I'm just kidding, of course. So it says, enter an arithmetic problem. Your expression must place parens around any multiplication or division operation. And we're going to do the 3 times 2 plus 1, a very small expression, little numbers, so we could do this in our head if it comes out wrong. I'm going to press enter. It says the result of your expression is 7. So let's do that in our head. 3 times 2 is 6, plus 1, that's 7. And then you can test this however many times you want. You can add on to this, right? There's other ways to improve this because we did have stringent requirements for it. And that's going to do it for stacks. So this program added on to what we knew about stacks from before. So at this point, we should feel comfortable using them. If you don't feel comfortable using stacks, or if maybe there's something you need a little more clarification on, especially with this code, I think this thing had a lot of moving parts to it, feel free to ask. I'm always available, and I love helping you guys. So I hope that you all have a good week, and thank you so much for listening, and have a wonderful day.